Hello and welcome to this Infoblox DNS DHCP Fundamentals webinar. My name is Michael Lansky and I'll be your presenter. This is my 6 addressing DHCP troubleshooting conversations. An auto run of this presentation takes about 15 minutes. Let's quickly review the table of contents page before. This slide is your table of contents. During the presentation, you can click on the TOC link to return here at any time. Each bullet item up is a link to that topic, allowing you to navigate the presentation as you see fit. Switch networks do complicate the life of a network administrator in regards to troubleshooting, but by using tools on the devices themselves, as well as use switch's ability to span or mirror ports, you can find out what is going on between the client and the server. On the client side, the use of the ipconfig command in Windows and Mac OS is very helpful. The details of some of the most important differences can be viewed by clicking on the links shown under Extra Notes for both. On the server side, the use of protocol analyzers and logs, such as syslog, is key to helping you see what is happening. Let's take a little look at a commonly used network analyzer. A very popular, widely used, and free analyzer is Ethereal. It runs on many platforms and can be downloaded from the website shown. This is not the only analyzer available, and you are more than welcome to use the analyzer of your choice. The next few slides, however, will introduce Ethereal and give you enough information to get started using it. You can use what is discussed here and apply it to your analyzer of choice, too. Once downloaded and installed, get started is straightforward. Start up the program, pull down the capture menu, interfaces. Select the one you want and click Prepare. You should configure your capture options first by selecting which port you want to focus on. You can also just use the word bootp to capture all DHCP and bootp traffic, as well as any ping packets that may be generated by the server. Other setup features worth noting include disabling promiscuous mode for wireless environments, configuring your capture to display traffic in real time. You may want to leave these unchecked for high-volume networks, as the packets will scroll too quickly to be useful. Finally, click on Start when you're ready. A list of captured datagrams appears. Select one to examine. From the resulting report, look for the division in the packet bootp and DHCP information. Then you can click on any of the options to expand them for detailed examination, or any tool to see raw data in a nice dump format. Another popular tool is tcpdump. Many Unix admins have come to depend on it and its familiar command line interface, but this can also be found for the Windows Optum too. In this example, we've disabled DNS results, extended the results to 1500 characters, selected verbose mode, and filtered on UDP traffic, which has a source and/or destination port of 68. Some types of client devices don't use your DHCP infrastructure to obtain their IPs. They might be set up as PPP clients, for example, and get their addresses elsewhere. The network admin may still want to use DHCP to download other configuration information. In this case, DHCP Inform is used. DHCP Inform will also be used after a standard DHCP lease is obtained to gather additional information. In this case, a unicast DHCP Inform packet would be sent. In the real world of large internal corporate networks, administrators find it very helpful to break their networks into several subnets, designed to fit nicely into such topologies by using relay agents. One thing to note is that the client uses broad relations just as normal, but between the relay and DHCP server, unicast messages are sent. The administrator facilitates the proper allocation of IPs to subnetted clients by establishing separate pools for each subnet. Network architects have a lot of flexibility in designing the relay portions of their network. DHCP relay agents can be found on white box servers or built into many network devices such as routers and Layer 3 enabled switches. In this way, you can double up on the services provided by these appliances by letting them serve as your subnet relays. For redundancy, most networks are set up with one router interface. When using DHCP, the same rule applies. Multiple DHCP relay agents or multiple DHCP servers can be used per subnet. The rules for this are exactly the same as when two DHCP servers respond to the client. The client will send out a discover. The two servers each send back an offer. The client chooses the first and sends out a request for that address. Finally, the server that sent the offer sends an ACK. You can increase dependability of DHCP services by deploying multiple servers on single subnets. In between crashes, the servers can share the workload by competing for clients, giving faster service to all users. But what happens if one of those servers, say Bonnie in this case, crashes? In this scenario, all of Bonnie's leases will be lost, and as the clients try to renew, they will find that Bonnie is missing, so their old lease will not be renewed. Thus, Clyde can take over if it has enough IP addresses to serve all current clients. Failover technologies that include communications and syncing of data between servers might be helpful here. DHCP failover, simply stated, is the ability to take two DHCPs and have them act as one by backing each other up. They run in an active-active mode, meaning both servers will give out addresses, but they both agree to hand out only a subset of all available addresses, making sure that they do not duplicate. They exchange information so that they always know what the other has done, and send keep-alive messages to monitor each other. If, for some reason, one server has a problem or becomes unresponsive, the remaining server can take control of all of the addresses. DHCP, as we've already hinted at, can deliver much more than just IP address leases. There are a total of 256 DHCP options. Option 0 and Option 255 are reserved, so that leaves us with 254 usable options. Some options have already defined uses, and some are left unused so that the clients and vendors can use them as they like. There is also the concept of option namespace, which allows vendors to create their own unique numbering scheme for DHCP options, so the number of options that may be used actually increases every time another vendor namespace is used. When a client wants some of this optional DHCP data, it sends a packet with the request flag set. The servers respond with a packet with the ACK flag set and the requested data, if available. The options you need to use vary by device and manufacturer, but no matter what options are involved, if the client does not ask for the option, the DHCP server does not hand it out. Requesting an option that the DHCP server cannot supply is not considered an error. The server just ignores any option it does not have and fills in what it can. Voice over IP phones is an example of devices needing DHCP options. Using Ethereal, you can see these options in play. Now let's look at some common problems in DHCP installations. The first common problem is called DHCP wars because multiple servers fight over the right to deliver conflict service. This is caused by two authoritative DHCP servers, where one of them is configured incorrectly, thinking it's on the wrong network. In other words, the IP address of one server is incorrect. In this example, you can see that by adding a wireless router that happens to be DHCP enabled to the network, we add a bit of an issue. When a client broadcasts as DHCP requests back to the server, one server is going to send a DHCP NAC since it does not recognize the IP address or subnet. You might see this when some clever user brings in an old wireless appliance or even a small switch that may support DHCP, plugs it in, and finds that it works, except for the small inconvenience that it has caused everyone else in his network because of the war between the new device and the corporate DHCP server. So, how do you debug this type of issue? First, look at the client having issues. The output from ipconfig/all may contain a clue that what is happening. In this case, it names the manufacturer and the DNS suffix, helping you to narrow down your search. You may not know where it is, but this will help. Notice the IP address of the DHCP server is also listed. Since this doesn't always work, you may have to track down the offender by grabbing the MAC address of the device first before spending time with your switch's forwarding tables. Simply ping from the client with the incorrect IP address, which will cause an arbitrary in its tables. A missing relay agent can cut off an entire subnet of clients from their DHCP server. New leases will not be given out, and renews will not be done. Besides unplanned network or equipment outages, another common cause of this is security-related upgrades or new firewall installations. When the DHCP server cannot be reached due to a failed relay agent or many other reasons, Windows clients still appear to get IP addresses, which adds to the confusion for clients. Anytime you see an IP address that starts with 169.254 on a Windows machine, you can be sure that it was an automatically assigned IP address by the operating system itself and not from the DHCP server. You can verify this by noting that there will be no DHCP server IP address shown and the default gateway is not assigned. When clients complain about missing options they need, here is a logical process you can use to isolate the problem. With your analyzer, examine a transaction accused of being broken. Determine if the client actually requested the option. If not, your focus should be on the client. Then look at the result produced by the server and, if the answer is present, verify that it is in the right format. If the server did not send the option, check to see if the server was ever configured to deliver it. In this scenario, as you dive into the problem, you'll usually find that they can get to addresses that are local to their set but can't get past their router. This helps us know where to focus our attention. If the users can't get past anything other than their local network, run ipconfig and check for a default gateway. If it's missing, the client can't find the router, which effectively cuts them off from everything past the router. This is a common configuration mistake. Some errors, like an incorrect subnet mask, can cause all sorts of issues. If the administrator set the mask incorrectly, or the lease was learned by an invalid or correctly configured DHCP server, you can check the subnet mask to verify that it is correctly specified for the network the client resides on. Using the ipconfig command, you can force your Windows machine to both relay and renew its IP address. With the netsh, you can actually enable and disable DHCP. Using the ipconfig command, you can force your Mac OS X machine to both release and renew its IP address. If using DHCP, you can temporarily change to boot to force the client to send a release. You can also use ipconfig to review the response from the last DHCP exchange that took place. There are also options from within the network control panel that will allow you to force a renewal of your lease. In the next few slides, we'll use the tcpdump command to see the results of a new lease obtained by a client. In this slide, we see both a release and a new discover. In this slide, we see the tcpdump output for an offer. In this slide, we see the tcpdump output for a request. And finally, in this slide, we see the tcpdump output for an ACK. This completes the DNS DHCP Fundamentals webinar number 5. We thank you for taking the time and invite you to review all the other webinars in this series.